Hi everyone, my name is Adrien Joly. I'm based in Paris, France. It's a pleasure to be here today, so thank you for inviting me. Just to give a few words about my history with computer science. I've been a software engineer for about 17 years now, mostly working for R&D companies and startup companies. And I'm guilty of writing legacy code about 10 years ago in particular, where at that time I was working for a startup company in Paris. I was the first employee of that company. And I realized that it was legacy code when I came back to it a few years later, when the company moved on to another project. And I proposed to take over that code and make it open source. And I realized that it was hard even for me to get back into that code. So it was really legacy code, and I had to do something about it, especially if I wanted people to contribute to it online on GitHub. Over the last 3 years, I've been a consultant at Shodo, a French consulting company. And I have been acting as a tech coach for my clients, mostly on legacy JavaScript or TypeScript code bases, mostly on the web applications. And today I'm going to present an experience I had with legacy code for a client, actually, where we wanted to remove a legacy module from that code, and we had to do it progressively. And the method that we used in order to do that safely was to use AST Traversal. Don't worry too much about the techniques here. Of course, we will explain them during that talk. And if you have any questions, I'm following the chat on the main stage, so don't hesitate to post them there. If there is something that is not clear enough and you need me to repeat or to rephrase, I'd be happy to do so. So here we go. This was the introduction I just tell you. So tech coach at Shodo, mostly working on JavaScript and TypeScript. So this talk, as I said earlier, was based on a real decommissioning project. And today we're going to replay it on an open source code base, one that you may be kind of familiar with because I introduced it at the previous slide. It's the one that I was guilty of writing. So it's an open source code base called OpenWide, which is a social network about music. So it's a website to share music tracks that you found online and that you want to keep for yourself and share with other music lovers. So it was developed in 2012 and went open source in 2016, I guess. So we will reproduce that decommissioning that I did for my clients on that code base. It will be not exactly the same, but it will be very similar to the one I done for that client. And of course, you can reproduce the same method for your own project. So here we go for the story. Once upon a time, there was some old caching logic that had to go. That cache was used everywhere in the code. So here it's called usernames, and you see that it's called everywhere in the code base. So how can we get rid of it without breaking everything? That's what we're gonna do today. So in order to remove some code in a legacy systems, what I had in mind was 3 possible strategies. The first one was to replace the legacy implementation. For example, instead of having usernames, which is like a cache for all the users of the system, we can use a proxy that will send queries to the database every time the usernames are queried from the code base. So that will be an example. The second possibility will be to defactor, meaning that we want to duplicate that code so that we can remove the actual username symbol. So you will duplicate the code everywhere it's called. So, and by doing that, you have the flexibility of modulating that code. So you can make it specific for every color, which is not really possible in the first possibility. The third possibility is like a catch-all way of doing things. It's what I call progressive decommissioning. And you may know it as the strangler fig pattern or the ship of Theseus. And it consists of unplugging the legacy module from each color one by one. So this may take days or months to do so. So obviously, we decided to take the last one. The first option is very good if your implementation is very simple. Like in our case, it's not the case because usernames is like it's an object. Basically, it's an object that was stored in memory. And if we had to use a proxy to the database, it would become something asynchronous. So it's very hard to swap one with the other. In the case of the second strategy, it works if the code that you want to get rid of is very small and if you're sure that it's correct. In our case, the way the data was stored in usernames was not correct because there was some data manipulation before caching the user data into it. And the last one, as I said, is a catch-all. So if you cannot use the first one, you probably need to do the third one. So that's what we're going to do today. So after deciding that we're going to go that way for my clients, we started to unplug the calls to that legacy caching system one by one. But then the developer added a call to the legacy caching system. And this was problematic because this was a waste of time for us. Like if the team keeps adding references to the old system, we will never be able to get rid of it. And it's even worse if, or it can be worse if the developers, instead of calling the legacy system directly, they call code that indirectly depend on that legacy system. For example, if you call a function that calls the legacy system, that's an indirect dependency on that system. So it's also causing the legacy to be more relied upon, which is counterproductive compared to our project of decommissioning it. So how can we prevent dependencies on that caching module from growing over time while we are decommissioning it? So one first answer that may come to mind is to use annotations in the source code. For example, you could add a deprecation annotation so that your IDE displays every mention of that symbol and make it seen for developers that this is deprecated, you should not use it anymore. And it works great. It works in your IDE, it works in your tooling, in the CLI. So it's pretty good, but unfortunately, it doesn't work for indirect references, meaning that if a developer from the team calls usernames, you will see the line saying that it's deprecated. But if you call another function, like for example, the one in line 39, which is get user from ID, the developers will not know that this function relies on the deprecated symbol. So it's not helping in case of indirect references. So if we want to decommission that usernames symbol progressively, and we cannot rely on deprecated annotations, we need some way to detect these indirect references. So let me show you how we did it. Basically, I had to write a tool. My goal was that we have a count of indirect references, and every time developers will create new code, like commit new changes, we will check the new number of indirect references, compare it with the previous one, and make sure that it never grows over time. And if it did, the developer will be warned so that, be careful, you added new references to that legacy cache, so you may need to find another way to achieve what you're trying to achieve. So the point here was to give some feedback to the developers so that they don't add dependency on the legacy system. So I'm not going to go into the details so far. The only thing I wanted to show was that little script with a threshold here that is used to know at which point we need to warn the developer. And this script is nice because you can use it locally. For example, you can call check refs like this. Of course. If you do that, you run the script, you'll get a list of wherever username is called. For example, here you see that username is referenced by something called getUserPrefs. And then you see that getUserPrefs is referenced by something called sendInviteAccepted, and so on and so forth. And you for each reference, you can find in the code base where it is. And you see here from the indentation that it looks like a tree. So you get a hierarchical way of displaying these references. So you can go up and down the tree. So another benefits of having it as a shell script here is that we can also run it on CI. For example, here we were using GitHub CI, GitHub Actions. So we have a simple job here that just downloads the source code, install the dependencies, and then runs check refs. And this will make the CI fail if we go if we increase the number of dependencies, because in that case the script just returns a non-zero exit code. So that will make the CI fail. So that's it. I realized that I forgot to tell you something important. The source code that we're going to see today is in TypeScript, but you don't worry if you don't know anything about TypeScript or JavaScript. You can do exactly the same principle in any language. Okay. So let's go back to the slides. So if we want to recap what we want to achieve, we have that username symbol that we want to get rid of. And in order to get rid of it progressively, we need to track down all the references to it, being direct or indirect, so that we can warn the developers if that number of dependencies increases over time. So the way that we found to achieve that is to use an abstract syntax tree, which is one way to represent a code base, or more exactly to represent the code itself. Instead of having it as a text file, you'll get it as a tree that you can navigate. And the good aspect about that is that that tree is a structure that's much easier to navigate into, including from a script or from a program. So you can programmatically navigate into the tree. So you can create algorithms with it. So for those of you who may not be familiar about AST, I'm going to show you basically how it works. I'm not going to need that. So let's say that you have a source code, a TypeScript file that defines a function. And let's say that username is the name of a function, even though it's not really the case in our source code. And that function does a console log. So it prints to the standard output. What we call the AST is what is showing up on the right side here. So you get a tree, as I was saying, and the first element here is a source file, which represents the entire source code here. And then here you see that if I click on function declarations, all the function code here is highlighted. So it means that that block is a function declaration. And username is an identifier that is attached to that function declaration. And then the code, that the body of that function is what is called a block in the abstract syntax tree. And inside of there, you can see an expression statement, which is a call expression, and that accesses a property, the property log of the object console, and passes a string literal. So basically, you can explore your source code by navigating a tree. And that tree is both human readable and programmatically readable. So that's for a function name. Let's say that's the piece of code that we want to get rid of. in order to do that, we need to find the references. So let's say that on another line, we make a function call to username. Here, if I click on there, I see that it's matching an identifier, which is part of a call expression. So the identifier that I have here is the same as the one over there. So I can match the function declaration with the call expression. This means that I can find, for every function that we have in our code base, we can find the references to that function. So we can create not a tree for the whole source code, but a tree for all the references to the symbol that we want to delete from the code base. So basically, that's the idea that we implemented in order to get rid of that module. So how do we do that in practice? So the algorithm is pretty simple. First, we need to find in the source code where is the deprecated function or symbol. So we have to find its location in the source code. And then we need to find the references to that function. But if you do that, you only get the direct references to that function. If you want to find the indirect references, you need to repeat that process for each reference. You will also find the parent function that makes the reference to the deprecated function. So basically, you're looking for a function that is called by someone. That someone is part of another function, which may be called by another function, and so on. So you repeat recursively that algorithm starting from the deprecated function. More concretely, if you want to look at code, this uses tsmorph, which is a TypeScript module, which includes an AST. So it's able to parse TypeScript and JavaScript code, create a tree representation for it. And then it also provides you a few helpers to help you navigate that tree. For example, here we have a function called find references as nodes, which is provided for free by that module. It may not be the case in other languages if you use the built-in AST. It really depends of the language. But in our case, we're lucky enough to be able to fetch the references to the node that we want to delete. So that's very nice. So starting from there, what do we do here? Instead of doing a recursive function, in the sake of simplicity, I just created an array. So a list of references that starts with the references that we gathered from the first step, and that will be completed. So we will push more references as we go over all of the currently existing references and find the parent function for each of them, as I was explaining earlier. So this is a very basic, very naive implementation, but it's just to give you the rough behavior of that script. And then when you have all the references listed in that array, you're able to iterate through them and display them to standard out. So basically, you get a rendering that is similar to the one we saw before, where for each symbol, you find the references to that symbol recursively. And as you can see, if I go through the logs here, we find exactly the same nodes that we found from an earlier figure that I showed you. So basically, we find that tree again that I was displaying earlier. So now let's see how it really works. So previously, I had shown you a shell script, basically, and that shell script calls another script that this time is implemented in TypeScript based on tsmorph. And you see that the implementation is a little bit bigger than the one I showed you in the slides. One of the reasons why is that in JavaScript and in TypeScript, there are many ways to define a function. So, and this is not provided for free by tsmorph, unfortunately. So you need to evaluate different kind of functions. Also, you need to make sure if you do that, you find circular references. So I don't remember in which part this is being done, but there is some point where we are doing that. Yes, here. So if we find that a symbol was already referenced, we don't go through it anymore. Well, I will not go through the whole logic here, but basically it's a more elaborate version from what I show you in the slides. And at the end of the talk, I will give you a QR code or the URL of that project if you ever want to fetch that script and use it for your own project. So, but then now we are able to count the references to the symbol that we want to delete, which is a great start. We know how we want to proceed. We were able to count the references to warn the developers if they ever add some dependency on that symbol. But still, it's hard to know from where we want to start. In order to do that, we can reuse a variant of that script, which I will invoke using another shell script called top ref. So what we're going to do basically is find the trees, no, not the trees, the branches of that tree that are the shortest, meaning that we want to look the things that look most like direct dependencies on the function to delete. So we start with the easy one, and then we'll end with the most complex one. So we will, at the end, we will address the branches that are the deeper. So if we want to get the shallow ones first, I'm going to tail the output from that command, and it's going to show me. You see here, for example, we have one branch, which is a direct reference. So here we see that username is referenced by reposts, and we see that repost is a method from an object. So this may not be accurate. It's probably called from someone else, but because of the dynamic nature of describing properties in JavaScript, it may have not been picked up by the script. Either way, let's look at another instance in a file called follow.js. So here we see that we have two dependencies on the symbol that we want to get rid of in the same function. And this function is called follow, and it's an exported function. And we can see here as a hint that this exported function is probably API controller. So that's an endpoint. So it's not being called by another function in the code base, right? It's called by the web framework, and that's it. So this is the closest we can find to a direct reference to the symbol. So it's a very nice place to start with. So what we're going to do now that we have found an interesting place to start, we're just going to do it. We're just going to unplug that function from the symbol. So how to do it? My recommendation, as you can see, that code is pretty hard to read. We're not going to make sense of it. We're just going to apply some clean code practices and like simple, safe refactoring techniques to make it a little bit more easy to manipulate. For example, here we see that username here is used to access a user, and then when we have that user, we extract the name from it. And we do exactly the same here. So one first step we could do is to refactor here what's inside the parentheses. And we're going to extract it in enclosing scope. And we're going to call it user1. Okay, so here we have it as a constant. So it will be easier to manipulate. And we could do exactly the same thing for the second one. Factor, extract, user2. So I save to reformat everything. So now it's a little bit easier to manipulate, okay? It's still not perfect. We may be confused by whatever happens between the brackets here. So basically here we're generating a user ID by concatenating a string. It's very dirty. Don't do that at home, but for us it doesn't matter because it's not the objective of what we're doing right now. We just want to make it easier to read. So this is user 1 ID, basically. And this is user 2 ID. So now we have something a little bit clearer, okay? So what we want to do now is to be able to generate user 1 and user 2 without calling the deprecated symbol. So I'm going to comment these 2 lines, and we're going to do it another way, a new way. So in order to do that, we have a function that is called fetch by UID. You know this because I'm the one who wrote that code base, I must admit. But if you do some archaeology in the source code, you can find that function. It's basically a function that will go to the database, given a user ID, and return a user. So let's see how this function works. First, is it called anywhere? I don't think so. So let's find another reference. So it comes from something called user. User model. This looks a little bit better. Okay. I'm already inside the file. Okay. So the file that we want to import is this one. So let's get the relative path to it, and let's import it. So what we want is to import the function from user model. So here we go. And I'm lost. Where is the follow function? Here it is. So what we want to do is this. Okay, so how that function works, basically we need to pass it a user ID, and then we pass it a callback. It's called handler here, but it's actually a callback function that will be called whenever the user was fetched from the database. So this is very old school Node.js code. Again, don't obsess too much over this detail. We'll get around it. So basically what we want to do here is to pass the user 1 ID. And we want to pass it a function that will return the user. Unfortunately, here I would like to await that instead of passing an old school callback here. So what I'm going to do, sorry for non-JavaScript developers here, but basically the trick is to call a function that is called resolve. This will resolve a promise. And we do exactly the same for the second one, basically. Yes. So user 2 is we await the promise of a user fetch from user 2 ID. So, and I forgot parentheses here and here. Normally we should be fine. The only last thing we need to do is, in order to be able to await, so to run asynchronous function, we need to make the parent function asynchronous as well. And that's it. So here, what we did is that we replaced two direct calls to the deprecated symbol into more durable calls, because they go directly to the database. And that's the way we should fetch users in our code base. So now, before moving on, there is one step that we should not forget: to run check refs again. Normally, it should have decremented by 2 since the last run, and we need to make sure that we keep track of that. So now that we've made that modification, we have only 1,280 references, including the indirect ones, and we need to make it up to date here. So expected refs count goes from 1,282 to 1,280. So we have 2 less to decommission. And that's it, I think, for decommissioning that function. So let's debrief. So what we saw here is that this little TypeScript script was useful to count the references for the symbol that we want to get rid of, which is great, not only to detect whenever developers add dependency onto it, so it prevents it from growing while we are decommissioning that symbol. But it was also useful because it helped us create a map of where we should start from by counting the depth of each branch from that tree of references. So we could start by the easy one and then move on to the more deeper one. The perspective of that approach is that if we wanted to reuse the same script in other JavaScript code bases, for example, as I mentioned earlier, it will need some work because in JavaScript there are very many ways to define functions, and not all of them are supported so far by that script. Also, in JavaScript, it's very easy to make what I call dynamic calls, meaning that you will know the name of the function at runtime. And this makes it a bit complicated to do using an AST. What we could do also is to write a plugin for your favorite linter so that it could detect not only the first level, so direct references, but also the indirect references to your deprecated symbol. And we could also use a similar approach if you want to extract, say, a feature or an endpoint or a service from a monolith. If you have several API endpoints from your monolith and you want to separate them into microservices, for example, you could use a similar approach to find the call path from that endpoint and see where it goes in the code base. So basically, which files or which functions do you need to extract from the code base in order to remove that service from that code base. So it will help you split up your code base into multiple smaller ones without leaving a mess behind. Before ending that talk, I would like to give you a little bit of return of experience because at the beginning of the talk, I told you that I practiced that methodology for a client, a real-world client. Unfortunately, the code base is not open source, so I cannot show it. But I can tell you how it went. The first part was setting up the script for the client's code base. As you can see, the script is not that complicated, and it plugs very well into the CI system that the client was using. So it just took a few days to write it and test it and make sure that it integrates well. And it was pretty seamless to make it work for the clients. And for them, it was good because it was a way to monitor the progress on the decommissioning project. So the team adopted it automatically because the feedback was clear. Whenever you add a new dependency on that symbol, you get feedback immediately from CI. So, and with a clear message. So it was easy for people to understand what we were doing and how to not make the problem worse. The decommissioning process, at the beginning, we did exactly as I did today, meaning that we started with the low-hanging fruits, so the easiest calls to that symbol. And the whole team participated to that project. So they could learn all the refactoring techniques that were involved, and they were very happy to see the progress because everybody wanted to get rid of that function. But we didn't follow that same methodology until the end because I think maybe at 95% of progress, what happened was pretty fun. The lead developer of that client decided that, you know what, there is no much left. I think that I can unplug the 5 last references in one go. And there was no easy way to do it with safe refactoring techniques like we did. So it was a pretty risky move to do, but he was feeling confident. And Of course, I told him as a coach, I say, okay, it's a bit risky to do that. So you can do it as at the condition that you are able to recover whenever you put that in production. Make sure that you're able to roll back very quickly if it goes bad. And so he did. He did it during the weekend for some reason. But the first deployment after that failed. So there was a regression in production. He was able to roll back very quickly, so it was okay. And then, thanks to the feedback he got by deploying to production, he was able to make the fix, the missing fix, and to make that last step work. So he was able to deploy a working version of the code base without the legacy caching system. So it means that we finally reached the objective of getting rid of that caching system. And he was very happy, as much as the rest of the team. And why was it great for the company to remove that caching system? It allowed them to do many things that were impossible before. For example, it was an API code base that they were running in a cloud environment, in Google Cloud. And when you want to scale your system up, because you have a lot of users at the same time, you need your cloud provider needs to start several instances to cope with the scale, right? So it means that every instance should start very fast. Otherwise, the cloud operator doesn't know if it's working or not. So before making that change, the cold start was about, I think, 30 or 40 seconds, which is a bit long. After doing that, we went down to less than 10 seconds, if I remember well. Which was a game changer in terms of elasticity and scalability for the system. Another project that was made possible after decommissioning was that the team was finally safe to update the database schema. They wanted to make some changes in the schema to rename some columns, etc. And they didn't do that because their caching system was not a pure cache. It was manipulating the data, meaning that the structure of the data from the cache was not the same as the one from the DB. They were not synchronized anymore. So it will cause a lot of confusion if I started to manipulate the schema of the database. After doing that, there was only one structure for the data, so it makes it easier and safer to update the schema. The third part is that it made it possible finally to separate the domain logic, so business logic, and the infrastructure code. Because in the past, because of that cache, there was some coupling between that logic and the infrastructure, making it impossible to separate the two. And that code was so complex that we were not sure how to split it before decommissioning that cache. Also, it set up a clear path to extract services from the monolith. So they were able to separate some APIs in different code bases. Whereas in the past, everything was coupled because of that common cache that were used from all the APIs. So yeah, the client was very happy about doing that. In conclusion, if you had to do something like that for your project, being a professional project or side project, it doesn't matter, on the legacy code base, if you want to get rid of something, I would recommend you to take the time to find a strategy that fits your project. Here, we decided to do a progressive decommissioning. As you can see, it's not an obvious way to do it. It will be much simpler to do inlining or replacing, as I showed earlier. If you decide to go with a progressive approach, like we did, we thought it was a good idea to use an AST because it prevents developers from adding dependency on the thing that you're trying to get rid of. And also it gives you a map that is very useful to help you plan in which order you want to proceed with the decommissioning, starting with the easier part. We didn't cover that in the talk, but of course, when you're making risky changes like the one we did, it's important to have good test coverage. not only about having a high coverage number, but making sure that if you did something wrong, your automated test will find it and you will get quick feedback. Another way to get feedback is to make sure that you deploy very frequently in production and that you're able to roll back very fast as well. Because even if you have 100% coverage and it's good quality tests, you will always find situations in production that you are not prepared for. So you need that feedback to make sure that your refactoring was correct and that it doesn't break anything. And I would advise to make a deployment every time you remove one dependency on the deprecated symbol, so that if it fails, you know why it fails. You know from which part of your code you failed. I don't know if there are many French speakers among us, but just in case, if you liked the way the demo went about decommissioning, you should know that last year, with two colleagues of mine, Jordan Nouri and Julien Topsu, we are also working for Shodo, we gave a 3-hour talk, or almost 3 hours, which is also a live coding session with a lot of explanations on how to manipulate, to refactor the same code base as today, but to turn some part of it into an hexagonal architecture. So it was very nice, because as you can see, the code is very legacy and dirty. So we had to clean it up a little bit first. And then we have to explain why it's important to separate business logic from infrastructure. And then we explain how to do it safely by introducing types just on that part of the code base, even though the code base is not statically typed. So it's full of tips that you can use, especially if you work in a JavaScript code base, legacy JavaScript code base. And if you don't speak French, it's okay. I provide a few references that help me a lot to come up with that approach. You probably know many of them. The first one is from Michael Feathers about working effectively with legacy code. The second one is from Nicola Carlo, and I say hi to him and I thank him a lot because he helped me review that presentation. It's called Legacy Code First Aid Kit. So it's a very practical guide on technical techniques that you can apply on your project when you have a legacy problem. And the last one is from Martin Fowler, and it gives you a lot of recipes on how to refactor your code in a standard way and in a safe or more or less safe way, depending on the techniques and IDE support. I think I'm done for today. You can find two links at the bottom of that screen. The first one is the source code that I presented today, and more specifically, the pull requests in which the same changes that I did today were made, if you want to reproduce it. And the second one is the abstract syntax tree sandbox that I used earlier to demonstrate how an AST works. Also, another link is my personal page, adrienjoly.com/pro, where I describe the kind of services I provide for my clients. So if you think that your company or another company needs some assistance to help the development team deal with legacy code, tech debt, or accidental complexity, feel free to contact me. We'll see if it makes sense to work together. Thank you so much for your attention, and I will stay here for a little while to answer your questions if you have any. And thanks a lot for MenderCon for having me today.
Awesome. Yeah, thanks so much for that presentation. This is a really fascinating technique. Looking forward to digging into it further.
Thank you. I provided my Twitter account. Yeah, it's a little bit old school now. There are so many alternatives to Twitter, I know. But yeah, you can find me there at Adrien Joly. If you have any questions, being in private or in public, doesn't matter. I will do my best to help and to provide examples. Also, if you want to practice your refactoring skills, don't hesitate to go to the OpenWide code base that we use today. It's a very fun sandbox to experiment with these techniques. It's a bit complex, so you have to be ready for it, but there's a lot of good things to try over there.